Hello everyone. Welcome to the solution of LeetCode problem 98 named Validate Binary Search Tree. In this problem, we are given a tree and we have to determine it is a valid binary search tree or not. For a binary search tree, for a root, its left children value should be always smaller than the root and its right children value should be always greater than the root. So here, a valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys less than to the root. That means for a root, all of its left children's value should be less than the root value and all of its right children value should be greater than the root value. And both the left and the right subtree must also be a binary search tree. Now in this problem, we are given a tree. We have to determine whether it is a valid binary search tree or not. I hope you understood the problem statement. Now let's move on to the algorithm. We are using this binary tree to understand the algorithm. Here, the binary tree has the root 5, which has two children, 1 and 4, and 1 has two children, 3 and 6. Now we have to determine whether it is a binary search tree or not. For a binary search tree, all of the value in the left subtree of the root should be smaller than the root value, and all of the value in the right subtree of the root should be greater than the root value. So here root value is 5, but this right subtree value is 4, which is smaller. That violates the binary search tree condition. So we can say that this is not the valid binary search tree. But the question is, how can we determine which tree is valid and which is invalid? Here, we will use the in-order traversal. Now, the basic intuition is, if we perform the in-order traversal in a binary search tree, the visited node's value should be stored in a sorted way. Now, suppose how this algorithm works basically, we are at this node 5 and the in-order traversal, we will first traverse the left subtree, then add the root value, then traverse the right subtree. This is the algorithm. Now we are at this root 5. So now we will go to the node 1. But 1 does not have any of the left or right children, so we will store it. And we will return back to its parent, 5. Now, all of its left subtree of 5 is traversed. So we have to store 5 here. Now from 5, we will go to 4. And from 4, we will go to 3. So here 3 does not have any of the left or right children. So we will store 3. Now we can see that for 3, we will trace back to the node 4 and we will store the 4 here because all of its left subtree is traversed. Now from 4, we will get back to the 6. And from 6, we will get back to the 4. And from 4, we will get back to the 5. And from 5, we will return the DFS call. Now the sequence is this. And here, if this sequence is sorted, and for any of the adjacent value, if the next element is smaller than or equal to the previous element, or we can say that if the current element, suppose it is our index, current element 5, if our current element is greater than or equal to its next element, where 5 is greater than or equal to 3, we will determine that this is not a valid binary search tree sequence. Otherwise, if this array is sorted, we will say that this is a valid binary search tree sequence. And this is how we're going to solve the problem by using the in-order traversal. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function name is valid BST. which is a root as a parameter. Now we are calling an in-order function into the root, and inside the in-order function, if the root is null, we have to simply return. Otherwise, we have to simply recursively call the DFS function into the left subtree and insert the root value to the vector VC and recursively call the DFS function into the right subtree. Finally, we have to run a loop from 0 to the vector of size -1, and here if in any of the iteration vector of I is greater than or equal to vector of I plus 1, that means the binary search tree condition is violated. So the Boolean flag is binary search tree will initialize with false. Now finally we have to return the Boolean flag. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.